Let us review just a little bit, and I want to make sure that we know how to graph an inequality. So when x was greater than -5, remember that I did not include the 0.5, so I made an open circle around -5, and then I had an arrow going to the right. When I have y is less than or equal to 0, I can include the 0.0, so I'm going to fill that in, and then it's less than, so it's going to go to the left. Well, now we're going to apply this. All right, so I've got linear inequalities, and right now I am going to just check to see if this point is a solution. I would plug in the points just like I have before. I have 5 for my y. Is that greater than 0 minus 3? Well, 5 is greater than -3, so yes, 0, 5 is a solution to the equation. Now I want to know if the point 1, 4 is a solution to this equation. Well, 4 is less than 2 times 1 minus 5. 3 is 4 less than -3? No. So this is not a solution to this equation. So we want to be able to find all the solutions to a linear inequality. So we're going to have to start by graphing the inequality. Well, to do that, I'm going to graph it as if it were an equality. So essentially I'm graphing the line y equals x minus 2. So I've got a y-intercept of -2, a slope of 1. Because this is actually a greater than, that means that my line cannot be solid because that would include that point. So instead I'm going to have a dashed line where the to indicate the inequality. Okay, and I still have my arrowheads at either end. That y is greater than means I'm going to shade the area above the graph because it's greater than. So anything that is in this, just beyond this line up to the left, will be a solution to this inequality. One way to check that would be to pick a point. I'm going to pick something easy like 0, 0 and see if it is true, if it is a solution to this inequality. Is 0 greater than 0 minus 2? 0 is greater than -2, so I am correct in the way I have graphed these inequalities. First, I'm going to solve the inequality for y. So if it's not already written in the form y equals mx plus b, I'm going to change it to that form. Then I'm going to graph the boundary line. So I'm going to use a solid line if it's less than or equal to or greater than or equal to, because remember it includes those points, or if it's less than or greater than, I'll just use a dashed line. Thirdly, I'm going to shade above the line when I have an equation where y, or an inequality where y is greater than or y is greater than or equal to. And I'm going to shade below the line when I have an inequality where y is less than or y is less than or equal to. And I'm always going to check my answer. I think the easiest point to check is 0, 0. Let's look at an example of that. So remember, my first step is going to be to solve for y. This is not written in my slope-intercept form, so I'm going to subtract 2x from both sides. I've got 3y is less than or equal to -2x plus 12. Remember, I need to divide everything by 3, so I have y is less than or equal to -2 thirds x plus 4. I'm going to go ahead and graph that. That was my step 2. The boundary line will be at y-intercept of 4 and a slope of -2 thirds, so I'm going down 2 and over 3, and because this is less than or equal to, my boundary line will be a solid line. So I'm going to go ahead and graph that as best as I can. And because my y is less than, that means that my shaded area is below that boundary line. But I am going to go back and check to make sure that a point that is below the boundary line does satisfy the equation. So again, I'm going to pick my point 0, 0 and see if that works. Is 0 less than or equal to, this of course will be 0 plus 4. Yes, 0 is less than or equal to 4, so I have correctly shaded. I'm going to go ahead and do an application problem. I've got a French club that needs to earn at least $175, so I'm going to be greater than or equal to. In their bake sale, they're going to be selling croissants for $2 and baguettes for $5. So I'm going to write my equation. Remember, my inequality. Remember, this is going to be greater than or equal to $175. Because these are the number of croissants and the number of baguettes, I'm going to have to write this with a value for each. So at $2 for some number of croissants and at $5 for some number of baguettes, they have to total something greater than or equal to $175. I'm going to fix my graph here just a little bit so this is reasonable. X both sides, I've got 5y is greater than or equal to negative 2x plus 175. Then I'm going to divide everything by 5. I've got y is greater than or equal to negative 2/5 x plus 35. I divided everything by 5. So I could go ahead and graph this. I've got a y-intercept here at 35. So that means if I sold 35, oops, and I didn't label my graphs. These are going to be baguettes, and these are going to be my croissants. If I sold 35 baguettes, that would equal $175. Well, I could also sell, notice if I go back here and do the cover method, I can see that if I sell 87.5 croissants, I would also get my $175. So I'm going to go ahead and graph my x-intercept down here. But I've got a slope that I can graph then of negative 2/5. Because I've gone by 5s, I'm going to go ahead and multiply this by 10. Remember, I would simplify negative 20 over 50 to negative 2 over 5. So I've done nothing except make it easier to graph. So I'm going to go down 20 and I'm going to go over 50. So I've got this point here on my graph. So I can actually go ahead and draw this line. Because it's an inequality that includes the 0.175, I'm going to draw a solid line down to my x-intercept. And then I've got y is greater than or equal to, so I'm going to be shading in above the line. Okay, the other thing I need you to take note of is this is only in quadrant 1. Why is that? Because this is a real world example, I cannot sell negative croissant or negative baguettes. So remember to be graphing only in quadrant 1. My line ended on my x-intercept and on my y-intercept. Okay, so I have graphed my line, but I have not checked to make sure. So I'm going to see if 0, 0 would solve this equation. If it does, then I've incorrectly shaded. If it doesn't, then I'm in good shape. So is 0 greater than 35? No, so I have shaded on the right side, on the correct side of my boundary line. Okay, so now we're going to kind of flip it backwards. I'm going to write the inequality for a graph that I can see. So inequality, this is represented by a dashed line, which means that I'm either greater than or I am less than, but it is not equal to. I've got a y-intercept here of 1, so I'm going to go ahead and write down what I do know. I've got a slope, well, I can tell I've gone from here and to here, so I've got a slope, I've got a rise of negative 3, and I'm going to write down my slope. My slope is -3 and my run is -4. So my slope is 3/4 x. And I got to decide what I'm going to write for my inequality sign. And that inequality sign tells me that it is greater than. And of course it does not equal because it's a dashed line. But in fact, I'm going to go back and check a point, and I'm going to look and see if 0, 0 is a solution to this inequality. Is 0 greater than 0 plus 1? It is not, so I have written the inequality correctly. It is y is greater than 3/4, this is my slope of my line, plus 1, the y-intercept. Okay, I'm going to do that again. I'm going to write the inequality. Notice this time I have got a solid line, and that solid line tells me that that is included in my inequality. I'm shading above the line, so I know that it is going to be greater, my y is going to be greater or equal to, solid line, some number. I've got a y-intercept of -3, and I'm going to find my slope. Looks like I've gone from here to here, so I've got a slope of up to over 1, so I've got a slope of -2x, and my y-intercept of -3. So let's go ahead and pick a point. I'm going to try 0, 0. Is 0 greater than -2 times 0? So 0 or -3. 0 is in fact greater than -3, so that point is a solution to this inequality. So I have written it correctly as y is greater than or equal to -2x minus 3. Lastly, I'm going to go over a couple of problems. I'm going to let you try these on your own. Try pausing the video and check back in a minute, and I will go through the answer. So I've got my lemonade on here, and I've got my tea here. I know that my equation, my inequality is going to be 150 for, I'm going to set x equal to t and y equal to lemonade. So I've got 150x plus 2y has to be, they have to spend at most, so less than or equal to $12. And I can go ahead and graph. I'm at a y-intercept of 6. I've got a slope of -3/4, -0.75. So I'm going down 3 and over 4, down 3 and over 4. And in fact, that would be my my x-intercept. It is less than or equal to, so it is going to be a solid line. Again, I'm only in quadrant 1. And because it is less than, I'm going to be shading under the boundary line. So I've got a graph point here, and I'm going to test it to make sure that it worked. 0, 0. Is 0 less than or equal to 0 plus 6? Yes, 0 is less than 6, so I have graphed that and shaded it correctly. Writing an inequality to represent this graph, well, I see my y-intercept appears to be at -3. I've got y, I'm above, and the shaded region is above the line, and it is a solid line, so y is greater than or equal to my y-intercept of 3. And let's look at what my slope is going to be. And a run of -8. So my slope equals -1/4. So I'm at -1/4 x plus 3. Going to test my point 0, 0. Is 0 greater than or equal to 3? In fact, notice, I hope you caught this. That should be a -3. So my equation is y is greater than or equal to negative 1/4 x minus 3. If you caught that, good for you. All right, there is a post-video quiz. I believe it is number 19, but you can check on the website.